Alright, hello everybody. Welcome to another live coding on Uno Platform Gamepad APIs. Excuse me if there's any noise behind me because there's a exceptionally loud climatization. And without it I would die here of heat, so this is the only way I can go. Alright. Okay, let's get started. Today's stream is going to be about focusing on iOS and macOS Gamepad APIs, and specifically it's going to be focused on the input part of the API, because we have already the handling of connecting and disconnecting gamepads implemented. So today we'll be focusing solely on the input reading itself. And to get started, I will go here and make sure I have iOS set as the target. Nice. And let's launch Visual Studio then. All right. Good. Let's just get rid of this and let's see what we've got here. So the interesting thing is that Gamepad APIs are the same on iOS and macOS, which is a good thing definitely, because it's gonna require much less code in total to handle both. So the current code we have here is handling the connection and disconnection of gamepads. And I don't really remember the code here, so we have to check what it actually does and verify what's there. But I see there is an error, and that's caused by the changes that we made the last time actually. The gamepad edit event was removed, and we replaced it by the sync stop start stop event wrapper. So there is like now a wrapper property, or field actually, that we can use. Okay, I need to connect to my Mac first. Second time's the charm. All right. Okay. Seems good. All right, we're connected, and so the gamepad edit wrapper should have a property of event we can invoke, and the same thing will be here for removed. We're gonna have event invoke. So this should be the only change that's required after the changes that we made the last time. So that's good. And now let's check. Let's actually check if this successfully compiles. Yes, I didn't check yet, so I will run it on my iPad, and we shall wait and cross our fingers that nothing is going astray. In the meantime, we can actually take a look at the latest Uno Platform release, as we had a huge release last week, and it was 3.8, and there's a lot of goodies there. So let's go to releases, and let's see what it contains. So yeah, there was a big improvement for cursor support on GTK, so more cursors are now supported and they display properly. A huge number of changes related to calendar and calendar date picker, because this is a huge control which was ported from WinUI directly. So it's like probably or most likely the best and most complete calendar control that's available on any cross-platform framework, and it can handle all of the different types of calendars and all of the different types of culture specifics that you can come across. So this is a huge control, and I definitely recommend you to try it out and send feedback. Okay, we have some errors. No, that's just false positives. Okay, so then we have new features from our contributors, launching query URI support on launcher, which allows you to check if a given specific URI scheme is supported, and if not, you can handle it differently, for example. Then we can also have controls resources version property that allows you to target WinUI 2.6 at least partially without the new styles, but you can still at least target them on Windows. And then various other features like support for embedded Linux devices, improvements on border rendering, and like rounded corners on WebAssembly. Then this is an interesting feature. This is application and window activation and visibility. So you can now on all platforms check when your application was backgrounded, minimized, or restored. You can see when it was activated and react to those changes somehow. For example, stopping some timers or adjusting something in your UI to indicate that the window was hidden. So that's pretty nice. And there was a lot of other things as well, like application exit for shutting down your application on GTK and WPF, and also other things like additional WebAssembly templates for, we updated the templates for WebAssembly to use .NET 5. So that's now the default instead of .NET Standard. Yeah, and we made some additional improvements in the API. For example, we added the isViewMode as supported and try-enter viewMode async methods that were previously throwing not implemented exceptions, but now they are at least partially supported, and then it will not cause exceptions in your code anymore. So that's nice. Yeah, and as also a big one here, the grid control, which was replaced by the WinUI grid, which is far more capable, far more efficient, performant, and as grid is one of the basic and most key layout controls in whole UWP and Uno Platform codebase, then this is definitely going to be very visible in your applications for performance. And speaking of performance, there were many changes and improvements for general performance of applications as well. And that's all listed here. And as if you combine all of these changes, like making visual states and visual transitions lightly loaded, and also improvements on dependency property, performance, and so on, if you combine all of these, then the result is that the whole every single Uno Platform application is going to run much more faster. And it's especially visible for bigger applications. So if you compare Uno Calculator running on older versions of Uno Platform to the current one, you will definitely see huge improvements in startup time, as well as the performance and the actual performance when it's running. So that's about it. I can see we have a failure here. Yeah, this is just it's actually a warning that's showing us as an error. We have to avoid it similar way as we did in Uno UWP here. So it's we have to remove the warning itself, and to replace the linker safe attribute with the new assembly metadata is trimmable. So I will do it here. Okay, now it should hopefully build, and this change we will have to make a separate PR for at least. Okay, so I will do it right now, as we have time before it builds. I have a second cloned Uno Platform repo here. We'll stash these changes. Okay, let's go to this and let's make a new branch. And let's make the same change as we did just now in the code. So this attribute, this linker safe attribute, was deprecated in iOS for newer versions of .NET, and it's necessary to replace it with the new attribute. So just like this, it's all it's needed. But in the future we'll be able to use just this assembly metadata attribute instead of the linker safe, probably as well as on Android, but now on Android this is not yet deprecated, so we're keeping this for now. Okay. Let's make a pull request for this. Oh. That should be enough. Pull request created, and that's it. Okay. That's first thing we did, and just waiting for this build to complete. iOS builds are very slow, so it's not going to be easy. Well, actually, while we're waiting, let's do something else. Let's do something interesting. So I noticed that there is a new API to handle ambient light sensor on JavaScript. So ambient light sensor JavaScript. So this is the new API that's still experimental, but it's now supported on some browsers. Actually, so can I use for this one ambient light sensor? So yeah, this is definitely not correct. Oh, it seems like this is something else. Like, it definitely works on Chrome, for example. This is probably more accurate. So it works on Edge, on Chrome, even on Android. And so we can use this actually to implement ambient light sensor, because there is also this class in UWP, ambient light sensor UWP. So it's a light sensor class, which basically allows you to read the current light level using lux values. So this could be a very interesting API, because I haven't seen this done before in any cross-platform framework, and we can definitely implement it not only for WebAssembly but also for Android, because Android has one as well. So that should be ambient light sensor Android. So environment sensors, and should be somewhere here. So yeah, the light sensor also with lux, measure, and illuminance. So yeah, this seems like a nice thing to do while we're waiting for builds to complete. But let's go back to our build here. I will have to connect my iPad to the screen. Let's see. Mirror screen. Okay. Let's see. Good. All right, we're live. So here's the sample application, and let's scroll to Windows Gaming. Oh, Windows Gaming. And let's check if we can actually connect some gamepads. So we have no gamepads connected. I have the PlayStation one here, and I already forgot how to connect it to something. Probably with this button. I hope so. Okay. Let's see. Not really, no. What was the button? I have to search for it again because I forgot completely. So it's the create button as well. Okay. It's really not working. It's not pairing at all. Why? So I'm holding the right buttons, I hope. I still refuse it to do anything useful. Maybe now? The only explanation I can see is that it's discharged. So I will try to connect it. Let's see. I'm pretty sure I'm holding the right buttons, but it doesn't do anything. Ah, now it's in pairing mode, finally. Or it was for a very short time. It's probably really discharged. I have to charge it for a while. Yeah. Oh, now it's connected. Finally. Oh, good. That took a while. But yeah, now you're connected. That we can go here and refresh gamepad count, and we have one connected. We can observe connected and removed event. Let's try to connect the Xbox controller as well. So now it's connecting. And let's pair it. We are connected. Let's go back to the application, and we have two gamepads connected. That's perfect. So now what we can do is to disconnect one. Okay, I will disconnect it by removing the battery. And we have one now. And let's get it back. And two. All right, so the basics are working. So let's now go to implement the second part, which is the reading of the gamepads, which is not working now, and it's actually throwing an exception because it's not implemented in Uno, which is our goal here. So first things first, I will go into the samples app and I will update the sample to actually make it easier to show the buttons that are pressed. So instead of me having to click the button there, I will make some timer that will automatically do it for me, and will pull the gamepad status over and over again to see what's happening. So let's go and do a button here. Well, actually, it's gonna be a toggle button. It's checked. Xbind. Let's do view model. How to name it? The hardest thing in development is always the naming. So how do we name it? Read. Auto read. Let's do auto read for now. And okay, check automatically. Is checking automatically. All right, and we are gonna make it a two-way toggle button so that we can toggle it on and off, and it's gonna react to our changes. So we're gonna create that property here. Okay. We are going to add a field for it. Here. Right, let's make a getter for it. It's just simple retrieval. And setter, it'll be more complicated, so we will have to set the value, and then if it's checking automatically, then we're going to start a timer, and on alternatively we're gonna stop it. So let's make a timer. Dispatcher timer. Check timer. With interval of, let's say, how many? From milliseconds, 100 milliseconds, that's fine. And what are you complaining about? It's probably it. There's nothing else to set. But what we're going to do is to make sure that it gets stopped when we leave the page. So disposable. Create. So the disposables are wired up in the samples, and when we are navigating from a sample, these disposables are automatically disposed of. Stop. Okay, and what we do actually is, we actually have to also set the tick handler, and the tick handler is just simply going to get the current reading for the gamepad. Okay, so it's gonna call this method. So that's it. Now the check timer is gonna start when it's on and stop when it's off. That's fine. All right. I think that's enough. That should be enough. And let's start actually implementing this API, the get current reading API. So let's go to gamepad, and we need the generated class here. And for iOS, where is it? iOS, we are gonna implement this. Also from macOS. Good. Something else? Nah. I don't think so. Not interesting. No. Okay. Only this. So, let's just implement it. I'm going to go into the iOS file, and actually let's copy the signature from here, and we'll put it here as well, like this. And let's search for how to do it on iOS actually. So iOS game controller. Okay, so these are button names. That's gonna be useful. Let's open all everything. Programming guy is gonna be useful as well. Automatically connected. This is fine. It's fine. Get gamepads internal. No. All right, so working with controller elements. So this describes the buttons and axis and directional pad. Uh-huh. So the controller has multiple different profiles, which then tells you what it's capable of. Specific buttons it can have. Extended gamepad and micro gamepad. Let's see what we can handle here. So as we have a specific gamepad connected, play some music here. What about this one? So we have the GC controller here. So let's try to use it somehow. So the controller has various methods and properties, but we need the extended gamepad, micro gamepad. Both are here. Oh, it's motion. Oh. Motion data. Uh-huh. So this is maybe some kind of movement of the device kind of thing. Okay, we don't need that for now. So let's go to... So we have micro and extended gamepad, but we don't know which one is supported. How do we check for which one is supported? Okay, so determine which profile is supported. You can check the property, and if it's null, then it's gonna be unsupported. So the trick is that we have to make sure that we handle both the micro and the extended gamepad properly. So if we have the extended one, that's the default, and if we have the micro, that's a fallback for us. Extend it. We have gamepad reading. Well, actually, no. Let's do it like this. If it's not null, then we are going to read those values there. So all axes. So this is a set of axes. That's a set of buttons, D-pads, and elements. There are some specific buttons there. Some default values for the triggers. It seems like they have a general API for unknown types of gamepads, but the default features are there available directly on the class. Okay, so let's do the buttons first. So this will first check the buttons. So let's do a reading. Bad reading. New gamepad reading. This by default, everything is toggled off. And let's do the buttons one by one. So if controller extended gamepad button A, aliases. Is press is what we need. Controller. So reading or gamepad reading. Oh right, there's the buttons. Enum, and we get A here. And let's do the same thing for the others. So A, B, Y, X. Now left. Bumper. Bump stick is okay. So it's below buttons. Buttons. Left shoulder. And for there is shoulder left. Then right shoulder. And then also the pump sticks. Left pump stick button. Oh, okay, and there is all these are nullable. No, not these, but this one is. Why are these not nullable and that one is? It's probably not present all the time, so let's just make it like this. Make sure that it's actually pressed. And the left bump stick. The same is gonna be for the right one. And an end. What else is there? Not here, but here. So pedals. Pedals. We don't support that yet. Those are the new Elite controller, but pedals. Right shoulder, right thumbstick view, and menu. So okay, menu. Button menu. Button. Not sure if it's gonna be button home or options. Probably options there. Okay, these are also optional. This is not optional. This one is okay. So these we have. And there is also the D-pad. But that one is hidden somewhere, so oh, okay, that is the default D-pad. default. So there we have right D-pad. Okay, we don't need this. Only for the optional ones we need to check for true. So we have from left, right, up, gamepad up, oh, and down as well. Okay, so we have the else here. Return read micro gamepad. If controller micro gamepad is not null, and by default we return just new gamepad reading. Like this. So that's this handled, and we are going to have to handle the axis on the thumbsticks. So let's do that now. Reading. Oh no, actually, if controller or the extended gamepad left thumbstick. Oh, left thumbstick x-axis value. Okay, so we can get the value here like this. So let's do reading left thumbstick x and just put in the value. The same goes for left thumbstick y and reading right thumbstick x and y. So all these are handled. Then we have also the triggers. Left trigger, controller, extended gamepad, left trigger, value, and right trigger value, of course. Okay, got these handled. So this should be all that's needed for the extended gamepad, right? That's all the buttons or D-pads, all the thumbsticks. So let's return reading. And now let's do the same thing for micro gamepad. Private gamepad reading, read micro gamepad. So for this one, we'll have a fairly limited number of inputs. So let's check it here. Not here, not here. So this is the extended one, but we need... Oh, here's a description of the buttons. But I think we have this correctly done. Hopefully, yes. The home button is not part of the UWP API, so we'll not use it there. Unless it's one of those buttons, the view or menu, that could be also a mix up there, but we'll see. Micro gamepad. The Siri remote, but I don't have a Siri remote. But let's just do the basics and we'll see what it does. So A, X, and D-pad. That should be doable. Button, menu. Why not? So let's take... Let's copy this. Oh, actually, from here. So it's gonna be micro gamepad. Button A, button B, and then the D-pad things. The whole thing goes here. What am I complaining about? Button. Oh, it's button X, actually, not B. X. And for these, we have to just change the micro gamepad. Like this. It doesn't contain definition for D-pad. Oh, that's interesting. so the property on extended gamepad is called D-pad with capital P, but in this case it's lowercase p. So that's a sad error. Not sure if it's error in Xamarin, but or in the actual API here. So here's D-pad with lowercase everything. So I guess it's just a bug in Xamarin. Extended one. Yeah, it's lowercase. So it's bug in Xamarin instead of bug in iOS itself. Okay, so we have the D-pad. And we also need a button menu. Let's put it here. And again, micro gamepad instead of extended one. And that's it. That's it. I guess with that we should have all the bases covered. And we should be actually able to run it. Let's see. Let's build. Okay. iPad is ready. And while we're waiting, let's go to the second instance of Uno and let's start implementing the light sensor itself. Oh. Should actually update this. So let's go to Uno 2. We have .NET 5, which is good. And we will go with WebAssembly. All right, so light sensor. So this one will be interesting in Android and WebAssembly. But let's add the class everywhere, and we will just return not supported, which will make the life of developers who are using the light sensor easier. So let's just make it all false here. There will be some method like get default that will retrieve the default one. Okay, get default here. And let's copy the whole class into devices. Sensors. Okay, sensors. So it's gonna live here. So what do we need? Let's check the previous classes to see what the shared code does. So usually we have the instance there. We have type event handler for the reading changes. We have the get default method there, and just some methods to raise the events themselves. So nothing too special. It should be enough to have only those there. So max batch size no, report threshold no, device ID not necessary. Get current reading. This one is going to be into platform specific one. Device selector not yet. And this one is from ID async not even. And we just need to get default. So reading change we will need definitely. Okay. So let's remove this. And again, we will use the same thing as we did with the gamepad code here. We will use the start-stop event wrapper. Just check what happened here if the iPad. Okay, oh, it's launching. That's good. I'll just finish this what I started, and I will check how the iPad code works. So we'll do this private static start stop event wrapper, and the delegate's gonna be typed event handler light sensor reading changed event arcs. Reading changed event wrapper or wrapper for simplicity, and we'll just take this one and call it here. So add handler value and remove handler value. Nice. And to make it even better, I will add nullable enable, because that's always a good thing to make sure our nulls are safe. And let's change this, because we know that the getDefault method will return null for those platforms which are not supported. Alright, good. I think we have this handled. And let's go back to gamepads for a while. So I'll again connect my iPad. Here. Okay, let's go to Windows Gaming, current reading. And currently we have no connected gamepads, which is fine. I will connect the Xbox One and let's see what happens. Okay, I'm pressing the A button and we get buttons A pressed. So let's do A, B, X, Y, all of them at once. Nice. Right thumbstick, left thumbstick, left shoulder, right shoulder, and now left trigger. So pressing different, yeah, so the different pressure gives you different results. Same thing for right trigger. So now X coordinate on left thumbstick, right, up slowly, down slowly, right trigger, right thumbstick, left thumbstick, up and down. Perfect. Do button menu, button view, D-pad down, D-pad right, D-pad left, D-pad up, 2 at once. And finally, we can check if the share button has any meaning at all. But how do we check that? Okay, well, I will keep it pressed. And then just check what happens here. So for extended gamepad, should get okay, it's not gonna show up here because this always shows just the basic the properties that you are actually using, and others are linked away, so are not visible here. But fine, I think all of the buttons that are there by default are handled properly. So let's now check the same thing for the PlayStation 1. Okay. Start it. So A button, B, X, Y, left trigger, right trigger, D-pad right, D-pad down, D-pad left, D-pad up, left thumbstick, up, left, right, down, up, right, left, down, and the shoulders. Well, I think we have it done. So that's great. That's great. And one thing I forgot is a timestamp, because we don't have any timestamp, so it's hard to, compare two different readings and check their precise timing against each other. But it should be there. So let's just do that so that we have it complete. The reading timestamp is a, what is it? U-long. And let's see, I saw some timestamp there, so maybe it's not here. So extended gamepad timestamp, last event timestamp. That seems nice. Although the problem is it's a double, not a U-long. That could be a problem. But we'll see what's the type of the value there. Maybe it's just some kind of very accurate number, and we'll just need the milliseconds as on UWP. Okay, UWP gamepad reading. Gamepad reading struct, and it has timestamp. It's time where the state was retrieved, but it doesn't really say what's the meaning of the value itself. But no big deal. I think we can first try to just cast it, and we'll check with the debugger what it actually means, what it contains. We'll adjust basically based on that. So, and we need to do the same thing here for the micro gamepad. So, micro gamepad, last event timestamp. Okay. Let's run it again and we'll check what it doesn't. Maybe it's gonna be enough, but I cannot say for sure because I didn't see what the value is, and the documentation is very vague on this one. Actually, if we can go to samples app in the Windows version, let's pair this controller. Okay, I have a different version of the samples app here, which doesn't contain the gamepad. So that's fine. I will just ignore it for now and set it later. And see it later with UWP to compare what the value should be looking like and compare it to the iOS version. Let's wait for this, and while we're waiting, let's go back to light sensor. So for light sensor, I will now implement the get default method. That should return the default light sensor for the supported platforms, but for the unsupported ones, it should return null. So instead of having the value here, okay, I see. So okay, so the supported platforms will have this here. So those are listed here. If WebAssembly or Android, so these two will be implemented, and we will make another file for light sensor unsupported, and this will be the catch-all for the other ones, not WebAssembly, not iOS, no, not Android. Not awesome, and not Android. So for all other platforms, we'll just make sure to return null there. So we can basically add a private constructor to make sure it's not possible to construct the class, and then the get default method, which is going to be the same thing as this. So it's going to return null immediately. And it's going to be a private light sensor constructor. And just clean up this. That should be enough. So now all the platforms which do not support any light sensor API will just return null, which will indicate they are not, the sensor is not available. Okay, let's save it, and let's go to light sensor CS. So the important thing is to make sure to check if the sensor is actually present on that given device first. And I will just check how it's done on the other classes. So yeah, so maybe some newer one. Okay, so so it always makes sure to initialize only one instance as like a singleton, and doesn't check multiple times for if we already checked before. So I will just take the whole snippet of code here and put it here, because it's gonna be exactly the same. A nullable instance. I'm actually thinking this is necessary. It's this is quite complex, and instead of this, we could put the whole logic here in the light sensor class. We could do it like this, make it lazy, and make the initialization in the lazy constructor. This is going to be much easier because we will depend on the lazy class to make sure that an instance is attempted to create only once, and then once it's actually checked, it will not be attempted anymore again. So the lazy class is just the right tool for this type of work. And instead of this, the get default will just return instance value, which might be null if the light sensor is not available, but it's going to be very fast and without any additional code in the main class. Okay, so this will actually just call try create instance, which will be a private method that's going to be on the platform specific part of code, and it will try to access the sensor and create an instance of light sensor, and if it's not successful, then it will not return anything, just null, and that will make the instance null for us. Okay, so let's do light sensor WebAssembly, and we will add a private light sensor method try create instance, which will return the instance if possible. And just clean up, make this nullable. Oh, nullable enable, and make this partial as well. Okay, this must be partial as well as this must be partial, and this must be partial. So we have this try create instance, which has to be static because we have no instance at that time, and the instance must be also read-only static instance. Okay, I think we have finished the basic layout here. Oh, one more important thing here is needed, and that's the initialization of the wrapper for reading changed. But let's first switch back to the gamepads. We'll show you the screen. So let's go to Windows Gaming, current reading, check automatically, and let's see. Okay, so the timestamp I'll put a breakpoint here. So the timestamp looks like this. And the value let's do this. Okay, so it's a Unix timestamp, and not sure. So the format is seconds. Yeah, so this is in seconds. So this thing is in seconds, but this has additional precision, namely microseconds. So basically, what we can do is to multiply that value by 100,000, and that should give us the full value instead of just the truncated one. $100,000 like this. Seems quite reasonable, and we will see what it does when we run it again. Again, we have to check later if UWP has the same kind of values and what is the format there, so that we have unified the values so unified and it's predictable across all the platforms. But let's go back to light sensor now, and let's initialize this start-stop event wrapper. So to initialize this, we can actually go by the same approach that we have in the gamepad class. So we can make a static constructor that initializes those static wrappers. So this will be read-only static, and we have the static light sensor constructor, which will just initialize the wrappers. So on first, we make a method called start reading. On last, we are gonna call it stop reading. And there's no need for a shared lock. We can just let the class lock, make sure the locking mechanism is working. All right. So let's take this. And these methods will be needed here. Like this. And I was actually wrong. This is not this shouldn't be an static wrapper. It should be instance specific. So instead of this, I will make it instance base, and make it private constructor that will create it and initialize the wrapper. Non-nullable field must contain value, which is, and this is just complaining that there is already an implementation. Okay, this one, reading changed. Here. Reading changed. It's going to be implemented for WebAssembly and Android. Okay, cool. That seems good. And we also have the get current reading method, but we don't really need that, or probably won't implement it, because most of the time the sensor classes implementation non-UWP platforms don't have any way to get the current reading, and instead have just event-based retrieval implemented. So for now, let's keep it like this. And let's go back to some other class. And let's get in some inspiration how to implement the try create instance. So usually we have this snippet that calls an initialize method in JavaScript, invokes it and checks if it was properly initialized, and in that case just returns an empty instance of the sensor. With the trick that we have this JS type field, which it's a constant that makes it easier to reference the specific API in JavaScript. So let's do exactly the same thing here. I will actually take this whole thing, all of this, and let's rewrite it specifically for the sensor, for the light sensor. So I'll remove this because we have the constructor in the main class. Let's wait for this. The last reading, daytime offset, we don't need that for now. And the report interval is not needed either. But here we have light sensor as a result. Light sensor here, light sensor here, and this is nullable, so it may return null. Yeah, so for this one is done. We have start reading, it's gonna be the same. Stop reading, very simple, nothing too special. So yes, that's pretty nice. I think we can start implementing the actual logic in the TypeScript code. Nice. So let's go to TypeScript. So in the Uno UI WebAssembly, we have TypeScript, Windows, devices, sensors, light sensor TS. So, oh, our iPad is already running, so let's go back to it just quickly. The A power mirror, and there is Gamepad APIs, current reading. So let's see what happened after our changes. Okay, like this. Yeah, that seems good. So now we have the whole value there, and it does make quite a lot of sense. I think we can keep it like this and potentially tweak it later based on WP. All right, so let's commit these changes. So let's do it here. So we have this change, which is going to be pushed by a different PR, so let's not add it here. We have this change that we need, this one as well, this, and this is not a change, this is just a change in white space. All right, that seems good to me. Yeah, okay, let's do feed. Okay, let's check how we named the commits before. So get current reading. Okay. Get current reading on iOS and macOS. And we are done here. All right. So Gamepad is done. But let's return to our second task for the day. The light sensor, and let's get it implemented at least on WebAssembly, because that's going to be the interesting one. Android is going to be just the same old Android sensor handling, so nothing too interesting there. But on WebAssembly, that's pretty cool, because we are going to be able to see whether the light is coming on the device or not. That's pretty original and nice. Let's do ambient light sensor browser. I think it's not supported on iOS yet, so I'll just check that quickly. Can browser do? What can web do today? So there is this website, what can web do today? And you can test various sensors and APIs there. And one of these is the ambient light sensor. But as you can see, it's not supported in this browser. So it means the problem is that iOS doesn't support it at all. So let's just disconnect iOS for today. We'll need a different device for this. And the device is gonna be Android. Let me just get it ready here. Mm-hmm. Oh. Okay, OneDrive. It's taking too long for this phone. Mm-hmm. Okay. I think that's ready. So let's do a power mirror, mirror the screen, and connect to my Wi-Fi here. Okay. Right, mirror phone to PC. That's good. All right, here we go. My phone is connected. I will just need also a USB-C cable to connect it to the PC. Let's see. All right. So let's start implementing the sensor in WebAssembly. And for that, we'll go to the docs. So light sensor JavaScript. It's going to be very similar to the other sensor that you can come across in JavaScript, but so the values will be in looks, and there is a device light event that can handle this. The question is, how can I check if it's available or not? It's a good thing to know. Yeah, and there is this class ambient light sensor. But how do I check if it's available? Doesn't seem like there is a way. Maybe just checking if the sensor class is available itself. I guess that's the same thing that we're doing here in the other sensors. So for now, at least, it's gonna be the best we can do. I can actually take this whole thing and just started writing it because I don't really like writing TypeScript code, and I would make a lot of mistakes there. Okay. So that's interesting. My phone just died. I hope it's not because of this screen sharing application. So the light sensor class, I don't think it's gonna be already there in the TypeScript definitions, but because it's just a draft of the API. But let's try. You can check if it's there. Ambient light. No, I'm not getting any IntelliSense, so probably not available. So instead of that, I will just add the implementation. Okay. So ambient light sensor. And that should be defined on the window. We'll adjust this later, but for now, light sensor. Dispatch reading will be just one single number, lux, and ambient light sensor here. So we first check if the class is available, and if it is, we will make a method of that. Okay, I see that there is magnetometer. Okay, so it's just renaming the function. So ambient light sensor. It's a class. I don't need any reference frame. And for this one, this will be binding the C# method that we're gonna call when the reading changes. Ambient light sensor. So, okay, we'll suppose that we check for the availability of the sensor itself, but if it's not available and it throws exception when we try to create an instance, then we also have this catch there to make sure that we can log it properly. So this will change to this, and we'll check how the API actually looks here. So there's on reading and on error. This reading event listener is what we will need. So this is fine. Not sure about the permissions. I don't think there is any permission needed on Android. When I tested the API on Android browser, it didn't require me to add any permission. So let's just first suppose it's not going to be needed, but we'll adjust if needed later. Yeah. Good. Okay, so dispatch reading will just have one parameter there. And we'll have to change this to ambient light sensor, of course. The same thing here. Why reading change handler? It's here. Okay. So ambient light sensor. And the value that's gonna be there is not this. It's instead something else. come on. Oh, right. Wrong naming. It's a light sensor instead. So these are all wrong. And that's the reason why it's failing. And this should be light sensor. All right, that's better. So light sensor, ambient light sensor, and then the value. And I have to check how to get it. So they get it from sensor.illuminance. So it's gonna be illuminance. Like this. Why do we have just exactly the class that we need there? I don't think that we have any problems with that. Use capture. All right, because of the reading. Like this. It should be fine. Remove event listener. And start and stop. Is there any start and stop? Yeah, there is start and probably stop as well. Start. Let's check here. Ambient light sensor. So it has, it derives from sensor, so it has stop and start. So let's add those. Stop, void, start, void. And illuminance is a value, numeric value there. So I just do number. Okay. That seems like all we need. The event is called reading. That's hopefully right. Yeah, I think that should be okay. So let's. The final piece of the puzzle is the dispatch reading method that we need to have on light sensor. So let's go create that. Magnetometer. Let's steal this. Just simply stealing. But I wrote that code before, so it's not technical stealing. It's borrowing from myself. Oh, this. Hello, hello. Hello to the chat. All right. So Lux. So now we have to push the reading to the event itself. So reading changed event. Why is it not doing? Okay, we need the instance value, and we do reading change wrapper event invoke, and we need the event changed arcs. So let's go grab those as well. License reading change event arcs. Let's take all this. Right. Oh, there's also a light sensor reading class that we need. Let's grab that as well. It's this one. All this. We'll implement the main class itself. We'll implement illuminance in Lux. And the timestamp, quite possibly. And not these. These are not really important right now. And light sensor. Where is it? Here. Okay. Light sensor reading CS. All right, and let's implement the class itself. It's just gonna be mainly about this property. It's gonna be settable internals. It's gonna be in private setter, so we don't have to use it either. We just have this one. Just getters for these two, and just remove all of this. Yeah. And finally, the constructor. It's gonna be internal light sensor reading with two parameters: illuminance and the timestamp. Okay, that was just false positive. So we have light sensor reading. And here we just return that reading. So yeah, internal constructor again. Light sensor reading. Oh, yeah, it's fine. So reading. Set it. So that's it. And finally, we will actually call this. So in this dispatch reading, we will first create an instance for that event arcs. Reading. We'll take the reading itself. Which is gonna take the lux value and the current timestamp. So date, time, offset, UTC now. And we'll post it here. Event arcs. So invocation is gonna be this and event arcs. No, not this, but instance value. That's the instance of the light sensor itself. Okay, let's make it prettier, maybe. So, sensor. And we will post it only if the sensor is not now. So, sensor reading changed, wrapper, event, invoke, sensor, event arcs. And that's it. Okay, so the last thing we need is to make sure this method is not linked out when the linker is doing its thing. So we can do it in the same manner as for the other sensors. And that's here in the Uno UI linker definition WebAssembly. We will find sensors and just copy and paste for light sensor. So this makes sure that the dispatch reading method is not linked out, even though it's not called by anything. it's called from the TypeScript code, so it has to stay there. Okay, I think that's it. That's it for now. And let's actually create some sample page to test this code. So I will close this for now. And just switch quickly to UWP and create the sample there. So UWP. It's always much simpler to build the UI in a UWP first and then switch to the other platforms. So I will do exactly that here as well. So the sample set is here. We need to create a new sample in Windows devices. Let's call it light sensor tests. Clean up this. The comments are annoying. And actually, as a simplification, let's again take one of the other files as an example, and we'll just do exactly the same thing here as on the other sensors. Let's take this, put it here. The value converters is coming from here. So the root is a content control that's checking if the sensor is available. Light sensor available. There's no sensor status. Oh, maybe we have it there. Attach reading changed. Yeah, and the only property is illuminance. So let's do illuminant. Yeah, and the timestamp itself, so it's here. Okay, and for the code behind, again, let's borrow this. Whoa, that's a lot of code, but we'll clean it up. It's not gonna be that much. It's gonna be... Well, actually, let's do this. Light sensor. Quick replace. And let's add the missing references. Okay, we don't need any accuracy there. We need just this and private float, I guess. Illuminance. We'll check for that. For dispatcher, light sensor, the default. If it's not null, we will create it. This is unsubscription from the event, then attaching, this is unattaching the event, light sensor availability, sensor status, that's just a string. We have illuminance and illuminance. Clean, clean, clean. We don't need any accuracy, we need just timestamp, and we will just read the illuminance from the class. So from the reading, we take illuminance in looks, and timestamp is already there. So that was quick. That was kind of quick. We also need to wire up the view model there. So let's do sample and view model type. So okay, name the sample first. And the name is going to be... Oh, let's keep light sensor tests to make it unified. But what... Well, actually, we have it like this, so I will make it the same thing. Windows devices, light sensor, description. Now I can just change this. And view model will be light sensor view model. Yep. And finally, we need a... We don't need a... we're using binding instead of xbind, so we don't need any property to expose that view model. All right. I guess we can now try to run it to see if it works. Even though I don't have any light sensor on this PC, we'll just see if the page is alive. And it should actually show us that light sensor is not available on this device. I see that we are setting the report interval here, which is probably not supported in the WebAssembly part, so we don't have to care about that. But we have to make sure that it's not throwing any exception. So we'll check for that later. Is it complaining? Is it complaining? Yeah, it's complaining about this wrong tag here. If errors, no, it's just false positives, nothing to worry about. Maybe I will start adding some of the finished code to a commit. So we have the test page. It's definitely going to be committed. We'll call it test light sensor, or maybe like this, light sensor sample. Let's first confirm that it's working before we commit it. Okay, Windows devices light sensor. So it's not available on this device. I expected that kinda. So, but the good thing is it's working. We'll just add some nice padding so it's nicer. I mean, 12 should be enough. No, that's better. And maybe some spacing on the stack panel. Yeah, that's better. Okay, so let's close this and commit the sample page. And let's now switch back to WebAssembly and actually test it. .NET 5. And let's run it on assembly. All right. Just verify if we didn't forget anything. But it seems pretty nice. Then one important thing that we will need is to connect our phone. I have to connect to my phone from to connect to the server from my phone, and I have this extension conveyor by Coyote, which allows you to actually do that quite easily. So I hope that will work, because otherwise I wouldn't be able to test it, because on my PC, of course, the sensor is not available, but on my phone it is. So let's get the page started. All right. I have to run it with the debugger connected. Stop it. No. So iOS Express. Progress is quite good. We finished the iOS gamepad reading on iOS and macOS, and now I'm just trying the ambient light sensor on WebAssembly. So once this is finished, that will be probably the end of the stream. But I hope it's gonna work. This is an experimental API, so anything can go wrong. So what's new on your side? Almost finished. Huh. What is React Will? I don't know that. Hmm. What does do? Oh, so a rich text editor. That's pretty nice. Yeah, but like on WebAssembly, it shouldn't be that hard to support like the rich editor text box and text block controls, because those could be based on HTML, and we could just translate the markup that's in UWP to HTML. So that could be possible to do. It would be much trickier on the other platforms, though, like Android, iOS. That would be quite tricky. And then Skia, because in the Skia we just recently added support for new lines, so there's a lot of things to do there to actually support proper formatted text boxes and text box. Hmm. The reason that these controls are easier for the web is that the web is markup language as well, so you can quite easily do these things there. Just quite hard to do on native side. Yeah. But like, we'll definitely have it in our backlog, so it's planned. Just not a definite timeline for that. By the way, I'm not sure if you saw, but we have a newly cleaned up backlog. So if you want to start contributing, maybe, then there are issues that you can look into. They're labeled by difficulty starter. Those are the easiest issues. So you can take those and try implementing some of those in Uno. So yeah, this is a good place to start. Okay, let's go now, Calhost, and let's try. Okay, I can run it on the PC, but I need to make sure I'm able to run it on the phone as well. So HTTPS, we'll need a SSL certificate. So oh, that might be tricky. If this dies so quickly, then we'll have to be very quick to actually launch the app on the phone. Mm-hmm. Yeah. Okay, so we will need to run it, and before it fails, to set up the whole thing here. So I download the certificate. Need to install it from files. Let's see. Downloads. What is the way to install it? So it has to be in it's tricky. Let's see when. No. This is weird. It's just failing all the time. Certificates. Yeah, I installed the certificate, that's good. I mean, I need to have HTTPS support for the sample app on the phone, because the sensors that I'm trying to use, the ambient light sensor, is only working when you have HTTPS. That's some kind of limitation that's there. Okay. Okay, the swipe control, that's already supported there. Yeah. Yeah, it's weird. I don't really understand why there's this limitation, but it's actually the same thing for the other sensors like magnetometer, gyrometer, accelerometer. All these are not working without HTTPS for some unknown reason. Like maybe it's some like a privacy security kind of limitation. Okay, let's try to run it on the phone. Oh, good. So where is my screen sharing? Okay. Okay, I'll be able to share the screen soon. Okay, here we go. Oh, it's not what they think for later. Okay. Let's go to devices, light sensor. So it's available. Okay. Oh, nice. So we have the illuminance there, and when I put it close to something very light, it increases and then decreases. And also when I put my hand there, it changes properly. Ah, it's just this error. But as you can see, the sensor is working correctly there. Okay, and close to the light. 5,000. Nice. So that's nice. That's pretty cool. All right, so it's a big success, I think. Like, I was afraid this wouldn't work, but first try actually. Yeah, so that's pretty cool, and that's all in the browser. Nothing else, no extensions, no specialties. It's just working. Well, why do you need which console do you need? Which console do you mean? But like you could use light sensor to create some kind of game. For example, you could use it to, for example, if you're making an application for watching movies, then you could react to that illuminance and maybe increase brightness if there is not enough light or something. I don't know. Yeah, like it could be definitely some scenarios where this could be useful, and because the API is in UWP, then we definitely need it here as well. So, oh no, not console support. This is a different project completely. The previous part of the stream was gamepad, iOS and macOS support, but that I already finished, at least the main part. So I switched to this for now. But okay, I think we're done here. So that will be the end of the stream, and I will be back next week probably to finish the ambient light sensor for Android, because there's also an API to support it. And we'll also return to the gamepad support, because I noticed that there is a gamepad API in GTK. So maybe we'll be able to implement like support for gamepad in GTK targets as well, like Linux-based operating systems. So that's gonna be interesting. Yeah. So that's it. That's it for today, and I wish you a great day, and see you next week. Yeah. Bye bye.